Hey there, and welcome. If you've ever felt like you're drowning in a sea of tech buzzwords like big data, data science, and SQL, you are definitely in the right place. Today, we're going to demystify that whole journey of data, all the way from how it's stored to how it creates those incredible insights that, well, kind of shape our world. All right, let's get into it.
I mean, just think about it for a second. How does your favorite streaming service just know what you want to watch next? Or how does your map app figure out the absolute fastest route home during rush hour? The secret to all of this, it's all in the wild and powerful world of data. And today, we're going to break down exactly how that magic happens.
So here's the game plan for today. We're going to start with the absolute bedrock, databases. Then we'll build on top of that to really get what data science is all about and the process behind it. After that, we are tackling the giant concept of big data. And finally, we'll tie it all together to see how this stuff impacts you personally every single day.
All right, first up, databases. You can think of them as these massive, perfectly organized digital libraries. They are the foundation for everything else we're going to talk about. Honestly, without a solid database, none of the cool futuristic stuff would even be possible.
So at its heart, a database isn't just a place to dump information. It's about managing it intelligently. And that's the job of the DBMS, the Database Management System. This is the software, the brains of the operation that acts as a super efficient gatekeeper, handling every single request to read, write, or update information, and doing it all securely and at lightning speed.
Let's see how all these pieces fit together. It all begins with us, the users, right? We ask the database a question using something called a query. The DBS, that brain we just talked about, intercepts that question. It then looks at the schema, which is just a fancy word for the blueprint of how everything's organized, to find the right pieces of data. It's this constant, super fast conversation happening behind the scenes. So why do we even need these complex systems? Well, for one, they are the engines behind every real-time transaction. Think about your bank transfer or that late-night online shopping purchase. That has to happen instantly and perfectly. They also make sure data is always up to date. And maybe most importantly, they provide that structured foundation that makes analyzing huge amounts of data even possible. And this is the key takeaway. Databases are the invisible backbone of pretty much every single app you use. From checking your email to playing your favorite game, there is a database working its tail off behind the curtain to make it all happen. Now, databases basically come in two main flavors. On one side, you have relational databases, or SQL. Think of a super strict spreadsheet with neat rows and columns. They're all about consistency, which is why they're perfect for things like banking systems. On the other side, you have NoSQL databases. These are built for total flexibility and massive scale. They love the messy, unstructured data of the internet. Social media posts, sensor data from your smart devices, all that stuff.
Okay, so we've got all this data stored away neatly in our databases. Now what? How do we turn that mountain of ones and zeros into something actually useful? Well, my friends, that is where data science enters the picture. You see, data science is this really cool mix of different skills. It's one part computer programming, one part stats and math, and one part deep expert knowledge about a specific field, like finance or healthcare. But the mission is always the same. Sift through all that raw data and pull out golden nuggets of insight that help people make way smarter decisions. And here's a little peek inside the toolkit. A data scientist uses big concepts like machine learning alongside specific techniques like sorting data into groups or clustering. And what tools do they use? Well, you've got programming languages like Python and R, and of course SQL, so they can talk to the very databases we just covered. It all connects.
Now, I want to be clear about something. This isn't just waving a magic wand. Data science is a really structured, methodical process. Think of it like a roadmap. A step-by-step journey that takes you from a vague question to a concrete, data-proven answer. And that journey looks something like this. You have to start by defining the actual problem you're trying to solve and then collecting the data. Then comes what is often the hardest part, cleaning that data. Real-world data is messy, it's full of errors, and this is where you fix it all up and start looking for patterns. Only then can you get to the cool part, building models, testing them to see what works best, and finally, deploying your solution out into the real world and monitoring it to make sure it keeps working. It's a full cycle.
But what happens when the data isn't just big? What if it's astronomical? What happens when it's being created faster than you can even blink? That right there brings us to the world of big data.
So, big data is pretty much exactly what it sounds like. We're talking about data sets that are so massive, so fast, and so complex that your normal computer or your standard database just, well, they can't handle it. It's a whole different ballgame that requires completely new ways of thinking and new technology to make sense of it all. The best way to get your head around big data is with the 5 V's. You've got volume, which is just the insane size of it all. Velocity, the incredible speed it's created at. Variety, meaning it's not just numbers, it's text, video, audio, you name it. Veracity, which is a reminder that this data can be really messy and uncertain. And finally, the most important V of all, value. The whole point is to turn all that chaos into something useful. So, how do we find that value? Through analytics. And it comes in 4 levels. You start with descriptive, which just tells you what happened, like a basic report. Then diagnostic digs in and tells you why it happened. Then it gets really cool. Predictive analytics uses all that info to tell you what's likely to happen next. And the top level, prescriptive, goes a step further and actually recommends what you should do about it. It's a journey from hindsight to foresight. Whew. Okay, we have covered a lot of ground here. We've gone from databases to data science to big data. So now, let's bring it all back home and look at how this incredibly complex world has a very, very real impact on your daily life.
Seriously, you see this stuff everywhere. That text you get from your bank about a suspicious purchase, that's fraud detection. Those creepily accurate product recommendations on shopping sites, that's data science. It's helping doctors predict diseases earlier. It's optimizing traffic routes to get you home faster. And of course, your entire social media feed is basically one giant, continuous data science project in action.
So there you have it. From a simple entry in a database to a complex algorithm that can help predict the future, the journey of data is really what's powering our modern world. And that leaves us with one last, really big thought. We have built this incredible power to collect and analyze pretty much everything. So the question is, now that we have all the answers, what are the most important questions we should be asking?